And now start our lecture with spatial orientation. Two types of spatial orientation such as kinesis and axis. Orientation means the act of placing an animal in a definite relation to the point of the compass or other fixed directive or stimulus. Orientation means the act of placing an animal in a definite relation to the point of the compass or other fixed direction or stimulus. It includes ways in which animals direct appropriate behavior responses to environment stimuli. An orientation response describes a steering reaction and may or may not be accompanied by movement. Because orientation precedes the behavioral response, it is regarded as one of the simplest component of behavior. Like the reflex, it can be modified by experience. Orientation involves single animals and being a type of pre-programmed instinctive or stereotyped behavior. It is built into the nerve system of animals. Such a built-in behavior is a necessity for organisms that live solitary lives and that do not have parental care, therefore lacking any opportunity to learn by imitation how to carry out certain actions. Spatial orientation or orientation on a local scale over a few centimeters or so to easily defined stimuli such as a light source or humidity gradient can be seen in many invertebrates. It falls into the following two main types: movement, in which animals attain their preferred habitat without orienting with respect to the source of the stimulus, that is the kinesis, and movements which are made at some fixed angles to the stimulus source, that is the axis. The first one was the kinesis, which is shortly represented as the movements in which animals attain their preferred habitat without orienting with respect to the source of the stimulus. Then next one is the stimulus movement, which are made at some fixed angles to the stimulus source. Fixed angles to the stimulus source. So let's learn about kinesis in detail. Kinesis, the simplest form of spatial orientation, is kinesis in which the animal's response is proportional to the intensity of stimulation, but it is independent of the spatial properties. Independent of stimulation, but it is independent of the spatial properties of the animal. Stimulus. The simplest form of spatial orientation is kinesis, in which the animal's response is proportional to the intensity of stimulation and is independent of the spatial properties of the stimulus. Only depend on the intensity of the stimulus. As a result of kinesis, an animal may arrive by chance in a favorable environment by which the intensity of stimulus is reduced. As a result of kinesis, an animal may arrive by chance in a favorable environment by which the intensity of the stimulus is reduced or entirely eliminated. Kinesis are the following two types: orthokinesis and clinokinesis. So first we can see a picture of a choice chamber for experiments on orthokinesis of wood lice. So orthokinesis, in the orthokinetic response, the animal alters its rate of movement according to the intensity of the stimulus. When the stimulus, which may be light or moisture, is of the right intensity, animal slows down and the spends most of its time under these conditions. For example, when wood lice are allowed to move about on course, one half of which is maintained at high humidity and the other half of low humidity, they scuttle rapidly over the dry half but slow down on the damp half. After a while, a cluster of animals builds upon the damp part of the gauze. So a lid can be seen, a wire goes platform, then the central partition, water on this side is keeping, and the anhydrous calcium chloride cloned on one side. Then the flatworm dendrocoelum sp showing clinokinesis. ഒന്നാമത്തെ എക്സാമ്പിളിൽ വുഡ്ലൈസിൻ്റെ എക്സാമ്പിളിൽ എന്താ കാണിച്ചിരിക്കുന്നതെന്ന് വെച്ചാൽ അതിൽ ഓർത്തോകൈനസിസ് ആണ് കാണിച്ചിരിക്കുന്നത്. The animal alters its rate of movement according to the intensity of the stimulus. And now next one is the clinokinesis, when the rate of change of direction of the animal increases as the intensity of a stimulus increases is called clinokinesis. An example of a clinokinesis is provided by a flatworm Dendrocoelum lacteum. If one side of a dish of water with some flatworms in it is covered with a dark cloth, the animals will be found to accumulate in the darkened area. In fact, they do this because they are escaping from the light. They are escaping from the light. It is because they move more slowly and turn more often in the dark. Another example of clinokinesis is provided by an unicellular organism, Paramecium, which exhibits clinokinetic response with respect to the local concentration of carbon dioxide. When the rate of change of direction of the animal increases as the intensity of the stimulus increased is called clinokinesis. But orthoclinetic movement, the animal alters its rate of movement according to the intensity of the stimulus. Here the animal is, altering the rate of movement according to the intensity of the stimulus. But in clinokinesis, animal increases its intensity of a stimulus increase. So in case of Paramecium, CO2 bubbles can be seen. It will arrange according to the CO2 concentration. Clinokinetic response of Paramecium in the vicinity of a CO2 bubble. When it senses a high carbon dioxide concentration, Paramecium withdraws, turns to a certain angle and advances again, but its new direction is unrelated to the direction of the stimulus. Now comes the next one. This is taxis movement. Locomotor responses by which an animal orients itself toward or away from a particular stimuli are called taxis. A taxic response is directional. So if the response is movement towards the stimulus, it is a positive response, and avoiding reaction is a negative response. With respect to the type of stimulus, a taxis might be classified as one of the following: thermotaxis, response to heat, phototaxis, response to light rays, stigmotaxis, response to contact, chemotaxis, response to chemical substances, hydrotaxis, response to moisture, rheotaxis, response to currents of air or water, and galvanotaxis, response to constant electric current, or geotaxis, response to gravity, and so on. Distinguishing features of taxis: it is a fixed action as well as a stereotyped pattern. Taxis is a fixed action and a stereotyped pattern. It involves spatial orientation. There must be orientation of the whole body. The direction of the movement should be continuously guided by the external stimulus. The direction of the movement should be continuously guided by the external stimulus. The orientation movement is directly proportional to the stimulus strength. The orientation movement is directly proportional to the stimulus strength. Now comes the phototaxis. Phototaxis is a directional movement according to light, and the direction of the movement should be continuously guided by the external stimulus, and the orientation movement is directly proportional to the stimulus strength. Phototaxis, the first one is the phototaxis. The mechanisms of photosynthesis, movement in relation to light source, have been studied extensively, mainly because most animals readily react to light and because light is so easily controlled in quality, direction, and intensity. For example, when the larvae of the housefly Musca domestica has finished feeding, it seeks out a dark place to pupate. At this stage, it will crawl directly away from the light source. It shows negative photosynthesis. Musca domesticയുടെ ലാർവ കാണിക്കുന്നു ഇങ്ങനെ. The maggot has primitive eyes on its head that are capable of registering changes in light intensity but are not able to provide information about the direction of light source. As the maggot crawls, it moves its head from the side to side, and the light on the left is brighter than that on the right. The maggot is less likely to turn its head towards the left. It will tend to crawl more toward the right, away from the light source. In response to an increase in the level of illumination, the maggot increases its rate of turning. Thus, although the animal has no directional receptors, it can perform a directional response. Similar behavior is shown by maggots of blowfly, Calliphora, Erythrocephala, and Euglena. Negative phototaxis and clinotaxis in a maggot. The unicellular flagellate euglena, requires light to carry on its photosynthesis.